Okay guys, so welcome to today's video. We are going to be looking at chapter 1H from the year 10 textbook, and that is going to be the length and midpoint of a line segment. Right, so let's get into the theory real quick, because who doesn't love a bit of theory? So if we have a set of axes here, and we have a point here and here, and we'll call this x1, y1, we can call this x2, y2, right? Well, what we can do, right, is we can figure out, let's do the midpoint first, right? So to figure out the midpoint, we'll do the midpoint first. What we would have to do is we would have to figure out what is the point in the middle, yeah? Now, just as a quick tangent, for those who have done a little bit of statistics, right? If you have a median value, right, and it's like you've got an even set of data, let's just go 2, 4, 6, 8, right? And the median is, well, how do we find the median? Well, we go and we divide the total number by 2. So 4 divided by 2 is 2. So we go 1, 2, and then we go 1, 2, don't we? And then from there, well, what do we do to find the median? We add the two numbers together and divide by 2, don't we? Go 4 plus 6 over 2 gives us, well, 10 over 2, which would be 5. And that's halfway in between 4 and 6, isn't it? So similarly, in order to find the midpoint, what we do is we take our x1 value and our x2 value, add them together, and we divide it by 2. And same goes for y. So, knowing that information, knowing that if we add and then divide by 2, right, which is basically averaging the 2 points, right? You take the total sum of points, which is 2 points, and divide it by the number of points, 2. Well, then you get the midpoint. So, the formula for the midpoint is big M, right? I personally think chocolate's the best. But we've got big M, and the formula we're going to write down is x1 plus x2 over 2, comma, y1 plus y2 over 2. And that you can sort of think of as like a big coordinate. And then, well, you would substitute in your points and solve and simplify, and then you would get the midpoint value. So that is that. Now, moving on to the distance of a line segment, or length of a line segment, I should say. So let's draw another set of axes. And we've got y and x here, and we've got the point x1, y1. And then we'll say up here we've got the point x2, y2. Now, well, what we can do, right, is we can, we're trying to find this value here. Now, to find that value here, we should figure out what the run is. We should also figure out what the rise is, shouldn't we? And so, by having the rise and the run, we actually make a right-angled triangle, don't we? And then we can use, well, there's this guy, you might have heard of him. He's called Pythagoras, and he has a formula that goes,
the sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
That's a right triangle, you idiot!
C squared is equal to A squared plus B squared, yeah? Now, if our distance is D, well then, instead of it being C squared, it's going to be D squared, right? And, well, the red bit is the run, isn't it? And how do we work out the run again? The difference between x2 and x1? Well, it's simply just going to be the difference between the two. So it'll be x2 minus x1 there. And the rise is the difference between the height of the 2 points, which would be y2 minus y1. So we would then get x2 minus x1 all squared plus y2 minus y1 all squared. And then finally, just to make it a bit easier on ourselves, to put it into a singular formula that we can quote unquote plug and chug, so to speak. Well, if we want to get rid of this squared here, if we just root both sides, what we get is we get d equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And that is going to be another formula that we're going to need to remember. So just to reiterate, we've got big M, chocolate's my favorite, which is going to be x1 plus x2 over 2, y1 plus y2 over 2. That's how you find the midpoint. And then our distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so then we're just going to go straight into question. We're going to go straight into question 2. We're going to skip question 1 for today, guys, because it's not that complicated to do that. But we're going to go with 2a now, and 2a says find the exact distance between the pairs of points. And the first one for 2a is we have 0, 4, and we also have 2, 9. Now, of course, we have to identify which one of these points is further to the left, because that will give us our